So.
This is a place defined by craftsmanship, not mass production. Mercedes Maybach S-Class and AMG models are produced in this Manufaktur department at the Sindelfingen plant in Germany. These leather hides are carefully selected and positioned to minimize waste. Each hide is scanned digitally under strong lighting systems. Technicians mark natural imperfections such as scars, wrinkles, or pores. Mercedes selects premium cattle hides, typically from regions where animals have fewer skin defects. Rough cuts are done by traditional hand cutters, while a high-pressure water jet cutter, up to 4,000 bar, handles fine shapes. Around 200 highly specialized employees work here, many of them long-tenured experts in fields such as leatherworking, stitching, trimming, and digital quality assurance. Each individual is responsible for their component from raw material to final quality inspection. Interior parts like seat covers, headliners, cushions, and even soft touch trims are sewn and finished with painstaking detail in the on-site sewing department. For decades, sewing, tailoring, and textile craftsmanship at this Mercedes-Benz factory have traditionally been professions dominated by women. Larger components like leather roof linings are assembled from many pieces stitched together with painstaking care. In this luxury Mercedes-Benz Manufaktur program, sewing quality is so critical that a single decorative seat seam can involve over 40 to 60 stitches per inch, meaning the operator must maintain perfect tension and alignment for long pieces of leather. This isn't a typical car factory production line. Instead of conveyor belts, the space feels more like a calm workshop, where skilled craftsmen and craftswomen work quietly and meticulously, assembling each car by hand. AMG Manufaktur adds brand-specific design and performance details to the interiors, such as custom AMG embroidery on headrests or floor mats, and unique stitching patterns or colors that reflect the sporty character of the brand. These features are all hand-stitched by the same specialists who create other Manufaktur interiors. The difference lies in the design, not the fundamental crafting process. At Mercedes-Benz's Manufaktur division, handcrafting a single car seat in the sewing and upholstery department takes about 4 to 6 hours for a standard seat and up to 12 hours for highly customized or intricate designs. So, unlike the main Mercedes assembly line, where cars are built on moving conveyors, the Manufaktur interior workshop is a quiet, handcraft-centric space inside the larger plant. This is roofliner leather covering process.
Yeah.
The leather is carefully adhered and stretched over the foam and substrate of the roofliner, with artisans ensuring it sits smoothly without sagging or wrinkles, even after years of temperature changes. This stage can take several hours, especially for custom orders with unique patterns, perforations, or logos. Upholstery for a full AMG interior can take tens of hours per car, depending on the complexity of customization. Though it's a highly analog craft, digital tools and AI assist quality checks, pattern layouts, and minimize waste. Still, final decisions are made by human specialists. Experience matters more than automation here. This provides an inside look at the facility for large components. As you can see, at each workstation, employees work together in a coordinated team. Since the Mercedes-Benz Manufaktur department you have just seen is also dedicated to Maybach vehicles, I will now show you how these cars are produced. So right now you have a unique opportunity to visit the world's most advanced automotive factory, Factory 56, located near the city of Sindelfingen. The process you are currently viewing is the welding of a car body in white. More specifically, these orange robotic arms from KUKA move the main body components and assemble them together. This is the flagship assembly plant for Mercedes-Benz luxury vehicles. In addition to Maybach, the standard S-Class and EQS are also produced here. All three vehicles are manufactured on the same assembly line. Right now, you're watching advanced joining techniques in action. Laser welding, structural adhesives, and precision spot welding, all working in perfect sync. That's why this process is often called robot dancing. The Sindelfingen site employs about 31,500 people in total, including roughly 19,000 in production roles. Factory 56 reportedly operates with around 2,000 employees, supported by extensive robotic systems and hundreds of autonomous guided vehicles. Now, after the final quality inspection of each body in white, the entire body is automatically transported to the paint shop. This Mercedes-Benz paint shop is built around one core idea: no wasted motion, no wasted energy, no unnecessary handling. The entire paint operation is engineered to reduce energy demand. Heat recovery systems capture and reuse thermal energy from ovens and drying stages. The paint booths operate with closed-loop filtration, where overspray is collected, purified, and reused to cut down on material loss and environmental strain. Car bodies move through the paint process fully automated. No forklifts, no manual transfers. Factory 56 was designed to dramatically reduce energy consumption through solar panels, direct current power grids, and systems that recycle and store energy. Inspection is continuous, not just final. Optical systems check surfaces between layers, catching imperfections before they become permanent. Sindelfingen has been a Mercedes-Benz production hub for 111 years and remains the company's global center of excellence for high-end luxury vehicles. This is where the glass roof is installed by a robotic arm. It comes as a pre-assembled module, already integrated into a carrier frame with seals, wiring channels, and mounting points. Alignment pins and reference markers guide it into place, ensuring a perfect fit into the body structure with no stress on the glass. Factory 56 reportedly spans around 220,000 square meters and delivers roughly 25% greater efficiency compared to earlier Mercedes-Benz production systems. Mercedes uses a highly automated marriage process where the drivetrain, suspension, battery systems, and body are brought together in a single precise assembly step. Right now, the chassis is being married to the body. Within seconds and with assistance from two workers, everything comes together smoothly. Over 400 autonomous transport robots navigate the factory floor, replacing the traditional assembly line. To make work on the chassis easier, the AGV carrying the Maybach can rotate the entire vehicle by 90 degrees. As you can see, Factory 56 does not rely on a traditional conveyor system. Instead, it uses autonomous driverless transport platforms, to move components and complete vehicle bodies from station to station. And right here, in final quality control, Maybach luxury vehicles are set apart from ordinary cars. That uncompromising focus on perfection is visible in every movement of the experienced quality inspectors. Every panel gap is measured digitally. Doors, hood, and trunk are checked down to fractions of a millimeter to ensure perfect symmetry and silence on the road. This production line supports V8 and V12 Maybach models, hybrid systems, and EQS electric variants. The electric drivetrain and battery for the EQS travel just 20 kilometers to reach the assembly line, highlighting a key advantage of Mercedes-Benz's local-for-local production strategy. Inside the manufacturer's studio, customers can watch their dream Mercedes being handcrafted and customized in real time. The system can personalize up to 20 vehicles a day, regardless of model. Although highly automated, Maybach production still relies heavily on skilled manual labor. These AGVs constantly communicate with the central control system. If one area slows down, traffic is instantly rerouted to keep production balanced. Laser scanners, cameras, and sensors detect people and obstacles in real time, allowing smooth movement even in busy zones. The same production line can build internal combustion, hybrid, and fully electric vehicles without requiring any changes to the factory setup. From the first automobile in 1886 to today's intelligent electric luxury vehicles, the company says its mission has always been the same: shaping the future of mobility. Employees are trained to use AI-powered manufacturing systems as Mercedes-Benz moves toward the next generation of intelligent production. Reports also indicate Mercedes plans to restore two-shift operation for the updated S-Class family due to renewed production demand. Mercedes-Benz is celebrating 140 years of innovation with a global journey spanning 6 continents and 140 destinations. Factory 56 is defined by luxury, digital innovation, and maximum flexibility, with a focus on ultra-precise, highly customizable vehicle production. Bremen, on the other hand, is built for high-volume manufacturing, prioritizing efficiency and global scalability to meet worldwide demand. This is how the production process of the Mercedes GLC begins at the Bremen factory. This plant builds up to roughly 300,000 vehicles per year, depending on demand and the model mix. It is home to more than 11,000 employees, making it one of the largest automotive employers in northern Germany. Over its history, Bremen has produced more than 10 million vehicles, a milestone that shows its scale and consistency. Mercedes-Benz GLC is one of its core models and is built directly in Hall 9, the largest production hall at the site. That same hall runs 3-shift production, meaning the line operates almost around the clock to meet global demand. This makes Bremen one of Mercedes-Benz's most flexible SUV factories worldwide. The same line can switch powertrains without stopping or retooling. Supply is split across Europe. Batteries come from Cummins, e-drives from Romania, and body components from multiple plants, all converging in Bremen for final assembly. Every vehicle then enters the final sequence: body assembly, drivetrain marriage, software activation, and quality control, all within one continuous flow. Right now, each GLC body is scanned for panel alignment. The doors, hood, and tailgate gaps are digitally measured to ensure perfect symmetry and consistent shut lines. Paint thickness is checked at multiple points across every panel. Too thin, too thick, or uneven, and the vehicle is flagged immediately. Inspectors don't just look, they listen. Door closing sound is evaluated for consistency, because even acoustics are part of perceived quality. Function checks run in parallel. Electronics, lighting, and sensors are activated to ensure every system responds exactly as specified after paint and curing. If anything deviates, even slightly, the car is pulled out of the flow and sent back for correction. No exceptions, no shortcuts. Those two factory workers work in perfect coordination, each on one side of the vehicle. The GLC line runs in 3-shift operation, meaning production continues almost 24/7 to meet global demand. The Mercedes-Benz GLC has been Mercedes-Benz's best-selling model family worldwide in recent years, consistently ranking as the brand's top-selling SUV globally. Total lifetime sales of the GLC and its predecessor, the GLK, have already surpassed 1 million units. Last year, demand for the new electric GLC was reported to be extremely strong, with early orders exceeding expectations and production being ramped up aggressively to keep pace. This factory employs approximately 11,000 people, making it the largest private employer in the Bremen region. This is the process of assembling headlights. Headlights arrive as fully pre-assembled LED or digital lights units, already built in supplier-controlled conditions with electronics, cooling elements, and optical systems integrated. Factory workers wear industrial protective clothing designed for both safety and performance. This typically includes flame-resistant jackets and trousers. They also wear reinforced safety shoes with steel or composite toe caps. In certain production zones, high visibility elements are required. Uniforms are issued either by the company or by suppliers, depending on the department. Watch how the front grille and rear bumper modules are quickly snapped into place. Independent reliability data and owner surveys suggest that this GLC model ranks below average for reliability in its class. Several recalls have been issued in recent model years, primarily related to software, steering systems, and safety electronics. Most reported issues are not mechanical engine failures, but rather electronics and software-related glitches. While some owners report a very positive and trouble-free experience, inconsistency in long-term reliability remains a common theme. From owner reviews, a common theme is, "Love the car, but the electronics are frustrating." Some owners report a completely trouble-free experience even after 90,000 kilometers, while others encounter issues within the first few months and experience repeated dealership visits. A smaller number of cases mention more serious faults, occasionally leading to long service stays or even buybacks, though these appear to be less common. The illuminated front grille on the newest Mercedes-Benz GLC is one of its most distinctive design features, especially on the all-electric version of the GLC. Right now, you can watch wind tunnel testing in action. This Mercedes-Benz EQE was primarily developed and aerodynamically optimized at the Mercedes-Benz Technology Center in Sindelfingen. The Sindelfingen tunnel is not only aerodynamic, it's also extremely quiet. For the EQS, Mercedes reportedly performed over 1,000 virtual aerodynamic runs before final wind tunnel refinement. Aerodynamics is one of the most powerful efficiency tools in modern cars. Even a tiny improvement, just a 1/100th reduction in drag coefficient, can increase driving range by about 2.5%. In 1984, the Mercedes W124 became the first production car to break below a drag coefficient of 0.3, a major milestone at the time. Modern Mercedes models refine aerodynamics down to the smallest details. Wheel covers that reduce drag, sealed body joints, fully smoothed underbodies, and even multiple rear diffuser versions depending on equipment. In some cases, even the wheels alone can significantly reduce drag. Full aero wheel covers can improve efficiency more than traditional alloy designs. The result is a constant engineering pursuit. Less air resistance, more range, and higher efficiency, without compromising Mercedes driving characteristics. For EV like this one, aerodynamics directly impacts driving range. Less drag means lower battery consumption, while quiet airflow is essential for cabin comfort and high-speed efficiency. That's why Mercedes heavily optimized the mirror shape, wheel design, door handles, underbody airflow, rear diffuser geometry, and cooling air management. The tunnel features a large rotating platform that allows the car to be turned to simulate crosswinds. Engineers use it to study stability and airflow behavior at different yaw angles, which is especially important for highway driving, where crosswinds can significantly affect EV efficiency. And that was the story of how Mercedes-Benz's most luxurious vehicles are developed and built. Now we can move on to the engine assembly for these cars.
But I think we should make this packing on 3 definitely a
vorher, ne?
Ja, mach mal.
komme ich gleich rüber. Beim C-Klasse Motor?
Nee.